Okay, so let's discuss a solution for this question number 11 in the sample questions, question bank. So here we have this DES Feistel function f that maps every 32-bit input R regardless of the to 32-bit string of ones. So if you remember what the DES Feistel function does, so it does something like this. So it takes a 32-bit input and then the 32-bit key and actually the 48-bit key that comes out of all this processing. So for every 32-bit input, it of course does this expansion permutation, gets this 48 bits, and we do the XOR with this 48-bit key, and then go to the Xbox process and all of these things, reduce then again to 32-bit. So basically, with this Feistel function, it takes this Ri minus 1 and this Ki and gives you a 32-bit output. And this 32-bit output in this case is all ones, is always all ones, 32 ones. So irrespective of whatever the key K is, as well as irrespective of whatever this 32-bit quantity for R is, always it outputs like 32 ones. So that's the scenario we have here. So in that case, given that the input to round j is say Lj minus 1 and Rj minus 1, we want to determine what would be as output or compute after every 2 rounds and after every 4 rounds. So now to do this, we need to just remember the XOR properties, that if I XOR say some bit A with the same A, then if the two bits of the XOR are the same, then basically the answer is 0, right? And if A XORed with 1, so if the other bit is also a 1, we get 0. If the other bit is a 0, we get a, so it's like when I say A XOR with 1, it depends. If A is 0 and XORed with 1, I get what? I get a 1. If A is a 1, XORed with 1, I get a 0. So this is same as A complement, and this is also same as A complement because this is my A, right? So that's why I say when A XORed with x equal XORed with 1, what we get is simply A complement. Now A XORed with 0, what we get is A. Why is that? A XORed with 0 means like if I 0 XORed with 0, it is 0. 1 XORed with 0, I get 1. So this 0 is same as this 0, and this 1 is same as this 1. So essentially I say I got my A, and here also I got my A. So A XORed with 0 is A. Okay. So now let's go through the details. So this is according to the Feistel function property. So output of round J is going to be R, so let's say Lj is simply Rj minus 1, and output of the right half is going to be, this is like the Ri, so just replace i's with j's in our case. So Rj is going to be Lj minus 1 XORed with this Feistel function Rj minus 1 and Kj. So that's what I have here. Okay, so what we have here is essentially Lj is Rj minus 1 and Rj is Lj minus 1 XORed with the Feistel function f. What it takes as input is Rj minus 1 and Kj. But we know that this Feistel function always outputs 32 ones, right? So it's going to output 32 ones, which I just represent as a 1. So Lj minus 1 XORed with, one second, let me go back to this. So Lj minus 1 XORed with 1, what did we have as a property? Lj minus 1. So anything XORed with 1, we get A prime. So Lj minus 1 XORed with 1, we get Lj minus 1 prime, simply the complement of Lj minus 1. So now let's go to the following round, j plus 1. So if we rewrite this rule, for round j, Lj is Rj minus 1. For round j plus 1, Lj plus 1 is simply, so replace j with j plus 1. So Lj plus 1 is simply Rj. Now we know from the previous case Rj is Lj minus 1 prime. So I just write that here. Now for round j plus 1, Rj plus 1 is going to be Lj XORed with the Feistel function f of Rj comma kj plus 1, because this is the round j plus 1. Now this is again going to be all ones, so it's going to be Lj XORed with 1, which is going to be Lj prime, and we know Lj prime, Lj is Rj minus 1, so Lj prime is Rj minus 1 prime. So what we have is, after the second round, okay, so we feed in Lj minus 1 and Rj minus 1 for round j. At the end of round j plus 1, or for every 2 rounds, we basically get the complement, because we feed in Lj minus 1, Rj minus 1, and what we get after 2 rounds is Lj minus 1 prime and Rj minus 1 prime. So which are the complements of Lj minus 1 and Rj minus 1. So let us continue. So let me remove these things here so we can go through it more easily. So for round j plus 2, this is going to be Lj plus 2 is Rj plus 1, and we know Rj plus 1 is Rj minus 1 prime. So we want to get back everything as Rj minus 1 or Rj minus 1 prime, or Lj minus 1 or Lj minus 1 prime, because those are the inputs to our round j. Now Rj plus 2, according to this, is replace j with j plus 2. So it's going to be Lj plus 1 XORed with f of Rj plus 1 and kj, but we know whatever it is, it's going to be 1. So Lj plus 1 XORed with 1 is Lj plus 1 prime. Now we know Lj plus 1 is Lj minus 1 prime. So Lj plus 1 prime is going to be the complement of this, which is Lj minus 1. Okay. Now round j plus 3, we have Lj plus 3 is nothing but Rj plus 2. From here, Lj plus 3 is Rj plus 2, and we know Rj plus 2 is Lj minus 1. Now Rj plus 3 is Lj plus 2 XORed with this Feistel function, but whatever it is 1, so it's Lj plus 2 prime, and Lj plus 2 prime is going to be Rj minus 1 prime, and the complement of that is going to be Rj minus 1. So we basically have at the round, so we feed in Lj minus 1 and Rj minus 1 to round j, go through round j, that is the first round, round j plus 1, that's the second round j plus 2, that's the third round, and round j plus 3, that's the fourth round. So at the end of the fourth round, we basically get back Lj minus 1 and Rj minus 1. So which means for every 4 rounds, so the 4th round, 8th round, 12th round, and the 16th round, so if we input the text as Lj minus 1, Rj minus 1 initially, what we get at the end after 16 rounds is also going to be Lj minus 1 and Rj minus 1. Okay, so that we can stop this.